Welcome to the Density Podcast. Today you're going to learn about density, what it is, and how you would solve density problems. Density is a physical property that tells you what that substance is. For example, if you have density, you can look at how much stuff there is in that sample, and if you consider its ratio of that amount of stuff over how much space it takes up or volume, then you can use that as an identifier for that substance. So how much stuff would be considered all of the material itself, the matter as we call it, and then it's contained within a certain amount of space, and that's the volume. So a ratio of the actual stuff divided by the space it takes up. Another thing to note, we're going to be doing some calculations, and we're going to be able to use the concept that mass is equal to density times volume. And we'll come back to this nifty little item that we can use to help us calculate different quantities in a minute. Now, density is an intensive property, and by the word intensive means it does not change. So no matter what, if you have a certain kind of substance, let's just say water, no matter how small of an amount you have, okay, let's just say that is a cubic centimeter worth of water, and inside that space is 1 gram of water. Say you had 10 cubic centimeters, okay, the volume, and then inside that space you had 10 grams of water, okay, and let's just say this space is now 10 times as much as this one, so 10 cubic centimeters. So what we're trying to show here is that the density of water is always a ratio. For every gram sample you have, it takes up 1 cubic centimeter of space. So the density of water is right around 1 gram per cubic centimeter. And if you just have 10 times as much water, it's going to take up 10 times as much space. So that's just an example of how water density is an intensive property. And comparing density, suppose you have 3 different metals. So you have copper, let's just say, you have zinc, and you have gold. Well, what are the same here? The amount of space that these 3 objects are taking up. However, how are they different? Well, it turns out that copper, for example, would have a lot of stuff in it that would take up the mass. So when you weighed that stuff out, it would weigh roughly 9 grams. However, for zinc, as you can tell by the table here, you have less stuff, so to speak. And so that one comes out to be about 7.1 grams in mass. However, gold, notice 19.3 grams per cubic centimeter. So there would be, as you can tell by my dots here, dots representing the mass, that there is perhaps a lot more stuff. And that would weigh more because you have more stuff. Okay, so here's an example, sort of a conceptual example of how the densities are different. Sorry for the lag. Okay, problem 1. Suppose you have a 4.0 centimeter cube piece of metal that has a mass of 10.8 grams. How would you identify the metal? Here's your chart of what the metals could be. Again, knowing the circle, knowing the circle, mass equals density times volume, what we could do, since these are densities right here, we can calculate the density, and here's how you use this circle. So it's density equals mass divided by volume. So you always take the variable you're solving for, and then look at where the other two variables are. If you have to cross this line, that's a dividing line. If you have to cross this line, it's a multiplication line. So right now you have density, and what's left are mass and volume, and notice how mass has to be divided by volume for you to get the other variable. So density equals mass divided by volume, and you can substitute in, so your 10.8 grams divided by the 4 cubic centimeters, and you want to put your units in because those are just as important as the numbers. So 10.8 divided by 4 ends up being 2.7, so we know this is aluminum. Remember the units, grams per cubic centimeter. Okay, example problem 2. What is the volume in cubic centimeters of 28 grams of gold? Again, you can take your circle, alright, mass is equal to, remember, density times volume. And this time you're solving for this variable right here. So in order to do that, volume is going to equal the remaining variables, and since mass is over density, it's mass divided by density. So m over d. And so now you take your mass, which happens to be 28 grams, divided by the density, or 19.3 grams per cubic centimeter. Okay, that's a gram. And you would get, as a result, 1.5 cubic centimeters. So right here you should get 1.5 cubic centimeters. Okay. Finally, example problem 3. What is the mass of a 50 cubic centimeter zinc sample? So again, you have a chart here which gives you information about the density of zinc. So you'll probably have to use that. Again, using your chart, you know that you've got mass is equal to density times volume. So since we're solving for mass, we'll just put m, or mass, is equal to d times v. Notice how I write the formula out, and then I substitute in underneath that. So the density of zinc, 7.1 grams per cubic centimeter, times the volume, which is 50 cubic centimeters. So what happens here, the cubic centimeters cancel, and so we have 7.1 times 50, or 355 grams of, in this case, zinc. And that's your answer. Okay, and that ends this podcast of density. See you next time.